Thank you everyone and welcome to this presentation on SolidWorks Sustainability. My name is Ramesh Lakshmipathy and I'll be your presenter today. So what is a sustainable design? There are several definitions you might find in textbooks, online, news articles, but I like to call it environmentally conscious design. It's a philosophy of designing products, building environment and services to comply with the principles of economic, social, and ecological sustainability. And really, the intention is to eliminate negative environmental impact completely through skillful and sensitive design. So, sustainable design is a call to action. It's a philosophy that can be applied in various fields, including engineering, industrial design, architecture, landscaping, graphics design, and even fashion design. So, why is this important? Now, a design convergence is occurring in many developed countries based on common concerns about climate change and future-proofing designs for an era of climate change, more expensive energy, and carbon neutrality. Energy consumption, for example, is bound to grow dramatically without much action to improve the energy efficiency infrastructure. Economic development and other factors such as competition and depletion of natural resources are adding to this challenge of meeting energy demands. The truth is that more and more consumers are moving towards energy efficient design. Greenhouse gases, mostly carbon dioxide and methane, have been linked to the warming of the planet, leading to potential climate changes. There are new economic pressures as well. So, for example, companies such as Walmart are requiring their vendors and suppliers to account for the environmental footprint due to the design and manufacture of their products. There are new regulatory standards. So, for example, within the government today in the United States, there's a new energy plan that focuses on increasing fuel economy standards and getting a 1 million plug-in hybrid cars on the road by the year 2015. And as all of you probably know, the Copenhagen Summit is just started last Monday, where world leaders are gathered to focus and discuss on the climate changes and its impact on the planet. The bottom line is that soon all the designs will be sustainable design and products will need to satisfy the quality criteria in terms of minimal impact on the environment. Here is a quick example of sustainable design of buildings who are probably the early adopters on sustainable thinking. Buildings consume 70% of all electricity in the US and are responsible for 40% of all carbon dioxide emissions. Now, in the year 2000, the US Green Building Council officially launched the LEED Green Building Rating System to help builders focus on some different values from a free market approach to instead on public benefits. So some of the things you would obviously notice in these green buildings are on-site renewable energies, especially solar and geothermal, external solar shading devices, atrium spaces integrated with the climate management system, triple glazing, use of water instead of air for cooling, radiant cooling systems, rain capture and water recycling systems, and efficient lighting systems. So with sustainable design, definitely these building projects are able to save on at least 30 to 40% on energy and 20 to 40% or more on water savings as well. So what's the business response from some of the corporate giants out there? Let's look at Walmart. Walmart is known as the world's largest retailer and is now looking at suppliers and vendors with this environmental labeling program to disclose the full environmental costs of making products, including everything from t-shirts to electronics. Walmart plans to determine the environmental and social implications of every product it sells and then label those products according to a universal rating system. On a separate initiative, Walmart has installed solar systems to power a few of its stores, especially in California. It has purchased renewable energy offsets. It has donated to environmental and social organizations and has instituted numerous other company-wide sustainability-focused initiatives. So who else is in the news? Well, in today's global market space, being a responsible company is often paramount to success. From shareholders to consumers, everyone is increasingly demanding products that are more environmentally conscious, if not 100% green. So some of the big corporate giants, as you can see on the slide, include PG&E, power company in Northern California, Google, AT&T, Lockheed Martin, Volkswagen, Panasonic, Mitsubishi, and many more. These are some of the big companies investing millions of dollars into sustainable design efforts. Well, if all else fails to prevent the environmental change, then here are some very cool but weird technologies that are being considered. Some of them may not be practically feasible at all, but may be the only viable option in the end. So, for example, cloud whitening, where the idea is to use satellite guided sailing ships to crisscross the oceans, constantly spewing a fine stream of sea mist into the clouds. Turns out that the particles, in this case, the salt in the sea mist, will cause the clouds to become denser, reflecting more sunlight back into space and keeping the planet cooler. Then there are space frisbee deflectors, which will be used to deflect the sun's rays with a cluster of translucent disks, each 2 feet in diameter, placed in an orbit between the Earth and the Sun. The number of disks needed for this job is really staggering, some 16 trillion of them. And according to a professor at University of Arizona, uh, the proposal is to build a magnetic gun with a mile-long barrel to shoot these disks into space. Even then, the cost is going to run into trillions of dollars just to do this. Then there is wave pump, a hurricane killer wave pump. And the idea here is that hurricanes rely on warm water for their strength. And the wave pump technology will deny them exactly that. And hence the hope that this may weaken the storms. Very cool technologies. If any of you are interested, this article, you can actually read this article on CNN.com, 8 Weird Ways to Save the Earth. If you search for that, you will be able to read this very cool and interesting article on the technologies that I just talked about on the slide. Now, there are several methods used in sustainable design. SolidWorks Sustainability uses the most popular of these, and which is called the Life Cycle Assessment, or LCA. LCA is used to understand the environmental impact of the design, starting with raw material procurement to product manufacturing to product usage, and finally to product disposal. LCA quantifies all emissions across each phase of a product's life and is defined by the ISO 14040 standard. So part of the LCA is to understand 4 important environmental impact factors. These are the carbon footprints, which is a design's carbon footprint consisting of greenhouse gases, carbon dioxide, carbon monoxide, and methane, and many others that the product releases and which can contribute to global warming. Air acidification. Air acidification refers to the burning of fossil fuels that can result in acid rain. And acid rain can slowly dissolve man-made materials such as concrete. Water eutrophication. Water eutrophication occurs when fertilizers reach coastal waters and cause algae blooms that can deplete water of oxygen, resulting in the death of local sea life. Total energy consumed refers to all the forms of energy the design consumes and releases over its life cycle. So why SolidWorks sustainability? So far we have seen that we have definitely understood that a product's greenness is a factor that more and more consumers are paying attention to. So consumers are increasingly considering the environmental impact of products they buy. They're not just looking at recyclability. They want to know about materials used and how the product is made. Manufacturers, on the other hand, are trying to respond to that growing demand. Now, as this influence grows in the market space, many companies see this as a new and unfamiliar challenge to their business because this will require new product innovation and applying new strategies in new ways that they haven't done before. However, companies do very well understand that this is a viable path into the future. Sustainable design is an important strategy that companies can use to reduce the environmental impact of the products that they produce. But up until now, how to do sustainable design has been a mystery to many companies. SolidWorks Sustainability has been created so that sustainable design becomes easier to understand and effortless to employ. Features such as real-time interactive dashboard, customized reports, and find similar material innovative selection tools really allows users to easily improve their designs and communicate their accomplishments in a compelling way. This is seen as so important that SolidWorks has included some of these sustainable design features in every seat of SolidWorks 2010. Next, we'll focus on the presentation demo, and this demo will definitely cover some of the features that's available in SolidWorks Sustainability. All right, one of the coolest things about SolidWorks 2010 is definitely the sustainability tool. When it comes to the environment, all of us have great intentions, but trying to gauge the environmental impact of the design can be complex and difficult. SolidWorks Sustainability tool is the first of its kind and the first in the industry, and the great news is that it's intuitive and easy to use. Let's take a look. Now, in this disk drive assembly, we're going to focus on the drive sled. So first of all, let me open this in its own window. The goal here is to use SolidWorks Sustainability to come up with the best material choice for the drive sled, which will have the least environmental impact. Let's launch Sustainability. One of the key things to note here is that Sustainability prompts us with information we already know about. So for example, the class of material. Let's use steel as the first choice. The name of the material is going to be AISI 1020 steel cold roll. That's done. Next off, I'm going to indicate what the manufacturing process used is. So let's say it's a stamped form sheet metal design. I can also indicate where this component is manufactured. Let's say Asia. And then it's transported and used in North America. What happens next is pretty amazing. Sustainability kicks into action. It queries an extensive database and tells us through an interactive dashboard below as to what's the design's environmental impact. There are 4 key areas reported: carbon emissions, energy consumption, air pollution, and water pollution. One of the things to note here also is that for each of these environmental factors, the program gives us a detailed life cycle assessment. So for example, if we're looking at carbon emission, we can get a breakdown as to what the carbon emissions look like during the material procurement stage, during the manufacturing stage, during the transportation and usage of the product, and finally during the end of life of the product. Graphical charts also appear, which enables the user to see how each design parameter influences the area of impact. This is really powerful because now designers have meaningful information to start making design changes. So for example, let's switch from a sheet metal design to an injection molded plastic design. It's so easy to do this in SolidWorks because all I have to do is switch to a configuration called plastic, where the material used is plastic. Go back to sustainability and change the class of materials from steel to plastics. I'm going to use ABS PC as my first plastic material choice. And you can see that in real time, sustainability compares the two designs in terms of the environmental impact. Clearly, it's seen that ABS PC seems to have a much negative impact on the environment compared to steel. So where do we go from here? What do we do now? Can sustainability suggest an alternative plastic material that we can use on this particular design? Well, absolutely. There is a cool and innovative feature called the Find Similar Materials option. So let's go ahead and see how this tool actually works. Since we are looking for an alternative plastic material, the material class is going to be plastics, and I can also go ahead and indicate some material conditions. In this case, I'm looking for an alternative plastic material which is much stronger than the current baseline material. And then let sustainability suggest alternative materials. Once I get the list of alternative materials to use, I can narrow down the list by choosing materials of interest. So let's choose acrylic, nylon 101, nylon 610, and PBD general purpose. Filter out the list, and now I'm ready to actually compare these alternative materials against my baseline ABS PC material. So let's start with acrylic. Right down below, you can see that the graphical charts automatically update, and this is extremely powerful because right away we can tell which material produces the desired results. Let's look at nylon 101 against ABS PC. This definitely is much better than acrylic. Let's look at nylon 610. The performance of this one seems to be almost compatible with nylon 101. Let's look at PBD general purpose. And obviously, this is telling us that this is not a good material compared with ABS PC. So it looks like nylon 610 is probably the way to go. So let's go ahead and accept that as the alternative material choice to use. And you can see that immediately on the dashboard, the program updates the environmental impact factors as well. Once we have the alternative design, sustainability then generates a vivid report of the life cycle assessment. Now, this report can be shared within your company and better decisions can be made. The good news is that this report is also stored as part of the design binder in the SolidWorks document. So there is no need to get concerned about losing this report. It's always associated with your SolidWorks document. Here is a quick snapshot of what the report contains. The reporting tool is very powerful in the sense that it captures every single piece of information about sustainability that we just performed on the drive sled design, starting with the model name, manufacturing region, usage, where it's actually being used, and what are the environmental impact factors comparing the baseline design to the alternative material design. So this report is complete by itself. And of course, you can always add and delete things from this report to make it complete. One of the other cool things is the ability to actually launch an online tool, which is nothing but launching a website where you can upload, where the design results are uploaded automatically. So here is a screenshot of the online tool. What happens here is once the design results are uploaded automatically, you can then compare your design with data on daily items that you're familiar with. For example, miles driving a car in the US, or a glass of water, or a television usage, etc. So now you have a good analogy as to what impact you're creating with your designs. In the earlier demonstration, we looked at the part level analysis of the drive sled model. All the functionalities shown there are part of the SolidWorks Sustainability Express tool, which ships with every seat of SolidWorks at no extra cost. Now, in the full version of the product, which is called as SolidWorks Sustainability, there are other key features supported, such as assembly level analysis, where the mode of transportation and energy usage of the product can be specified, and also you can understand the contribution of these two on the environmental impact factors. At the assembly level, you can also perform assembly visualization, which is fundamental and key to isolating good and bad components of your design and how individual components can play an important role on the environmental impact. A little bit later on, we'll also see how sustainability and SolidWorks simulation complement each other very well. Information provided by sustainability can be used seamlessly in SolidWorks simulation to predict and improve a product's strength and performance. Let's take a quick look at the assembly level analysis. Here is a humidifier assembly, which is composed of several components. Sustainability at assembly level works the same way as part level, except that here you can specify the mode of transportation and the energy usage. Let me show you real quick what happens when I switch the mode of transportation from the current boat configuration to the plane configuration. You can see that sustainability immediately kicks in and shows us the impact of the new mode of transportation in terms of the carbon emission, energy consumption, air and water pollution. Another great feature is the assembly visualization. So far, we are only familiar with things like mass, density, surface area of different components of the assembly, but now we have access to all of the sustainability features and our characteristics, which really helps us to focus and understand our design a lot more better. So things like, for example, air and water pollution, carbon emissions, energy consumption, manufacturing location, manufacturing processes, or different components of the assembly can very well be understood now. So let's say, for example, we want to use the carbon footprint as a means to isolate good and bad components of our design in terms of environmental impact. We can real quick sort out this list of components based on the value of the carbon footprint. One of the nice things here is that we can also take advantage of the slider bar here, move it up and down, and real quick isolate components of interest. Red is bad, green is good. So we can drag the slider and set it to a carbon footprint value so that we can isolate all the bad components of the design very easily. Or we can actually drag this slider, we can drag this bar at the bottom and filter out components of interest. So in this case, we're looking at the underbase and top cover components, which have the highest carbon footprint. So now we have access to these two components, and we can take advantage of sustainability and see if we can seek an alternative material which will improve the carbon footprint for this particular component. And we can repeat the same process for the underbase component, and thereby improving the environmental impact of these two components in terms of the carbon footprint. In this final demonstration, we're going to see how cool it is to use SolidWorks Sustainability in conjunction with SolidWorks Simulation, not only to understand and improve the environmental aspects of the design, but also ensure that the product's strength and performance is intact at all times. To illustrate this, I'm going to focus on the tank component of this humidifier assembly, but let's first open this in its own window. Now, the tank has to hold water, but we also have an additional requirement. Let's say this humidifier is sitting on someone's desk, and we put a bunch of books on the top weighing approximately 5 kilograms. So the idea is to ensure that this tank design is not going to break under the given loading conditions. So we have a pressure load, which is simulating the fluid pressure on the inner walls of this tank, and we have a force on the top surfaces simulating the weight of the books. Now, the current material is polyethylene, and under the given conditions, the minimum factor of safety on this design turns out to be about 3.0. Now, obviously, this is a strong design, but let's see if we can use sustainability to improve the environmental impact of the design. So the current material is polyethylene, and the next logical step is to go and seek similar materials. And obviously, we're looking for an alternative plastic material. So let's set the material class as plastics. And some of the criteria that we're trying to use in seeking the alternative material is that the density has to be similar to polyethylene, but the tensile strength has to be much greater than polyethylene. Once we get the list of alternate materials, we can quickly narrow it down to the materials of interest. And as I go to the right side, you can notice that under the tensile strength column, the PP homopolymer seems to have the highest tensile strength. So that seems to be a promising candidate at the moment. But however, let's go ahead and make sure that this material has a lesser environmental impact compared to polyethylene. So you can see that the dashboard here at the bottom clearly shows us that the PP homopolymer is a much better material compared to polyethylene in terms of the environmental impact. Let's out of curiosity see what happens when we choose PP copolymer material. Obviously, this also has a much better performance than polyethylene, however, not so good as the PP homopolymer. How about PE high density? Well, again, this has a much better performance than polyethylene in terms of carbon emissions and energy consumption, but then the air and the water pollution seems to get worse. So it looks like PP homopolymer is the winner. I'm going to select that and accept that as the alternative material choice. Now, what I'm going to do is go ahead and set my material in sustainability to PP homopolymer and watch what happens. When I do this, the SolidWorks material is automatically updated in the feature tree, and also on the simulation side, the material information is automatically updated. All I have to do is go ahead and test this new design for factor safety performance, and let's go ahead and do that. The new factor safety is about 7.0. it obviously has bumped up. But then this is really cool because now we have a chance to trim our designs and remove some weight out of our designs. So let's say we change the wall thickness of this tank from the current value of 2 millimeters to about 1 millimeter. And watch on the dashboard in sustainability will automatically update based on the new volume as well. All right. So once we have made the design change, let's go ahead and test this new design for performance and understand what the factor of safety looks like on this new design, which seems to be extremely environment friendly. All right, so new factor safety is approximately 2.0. So the product is still two times as strong as it probably should be. So this is a good design to go with because it's not only uh, uh, it's not only environment friendly, but the performance is still intact. Okay. So in a matter of minutes, using SolidWorks Sustainability and SolidWorks Simulation, we can come up with an alternate design that is not only environmental friendly, but also meets the required performance criteria. All right. I'm going to quickly recap with the next two slides on the two products that we have seen today. SolidWorks Sustainability Express, which is again a great way to do a life cycle assessment of individual components. There is a great material selection tool that that is innovative in nature and helps to seek alternate materials of choice with similar mechanical properties or different mechanical properties. The environmental impact dashboard is a great way of understanding the environmental impact over the life cycle of the product in terms of four factors: carbon footprint, air acidification, water eutrophication, and total energy consumed. You can also create full customizable detailed reports with links to an online calculator. And finally, it's available with every seat of SolidWorks 2010. SolidWorks Sustainability, which is the full-blown product, is again has the same functionalities as Sustainability Express, but also there are some really cool added features such as you can do the lifecycle assessment of assemblies. You have expanded reporting capabilities. You have support for configurations. You can specify the amount of and type of energy consumed during the life of the product and specify the mode of transportation as well. Assembly visualization, like we saw today, is a great way of isolating good and bad components of your design very easily. And again, it integrates with structural simulation to make sure that the performance of the product is still intact. I just wanted a real quick mention about PE International. This is the underlying technology used to perform the life cycle assessment in SolidWorks Sustainability is from PE International. This company is based out of Stuttgart, Germany. They have extensive experience and credibility in the space for many, many years. By partnering with PE International, we are providing users with very credible impact results, and all thanks goes to PE's 2 decades of sustainable design and lifecycle assessment experience. So what's the SolidWorks sustainability takeaway? It is definitely designed to help customers like you achieve environmentally responsible designs. It's easy to understand, it's intuitive, and it's effortless to employ. You can communicate your accomplishments in a very compelling way, and it's available to every SolidWorks users. So what does it actually mean to you as a designer or a product designer? You have the power now to dramatically alter how we interact with the environment. The question is how. Many designers don't know about the life cycle assessment process or how it could actually guide them to a more sustainable design. Others may think the process is too complex and time consuming or is someone else's responsibility. But now Learning about designing for the environment will put you ahead of the curve. With SolidWorks Sustainability, you will have the built-in environmental intelligence to make more informed decisions about what materials to use. And you will also see how region-specific material sourcing, manufacturing, use, and disposal will affect your product's life cycle before manufacturing actually begins. What does it actually mean to your entire company? As a designer or manufacturer, you have no choice but to address market changes. SolidWorks Sustainability is a tool that can help you stay profitable as consumers increasingly choose sustainability design products. Using lifecycle assessment information early on in the design process will help save your company time and money by avoiding surprising sustainability assessments and costly redesigns later on. So, as a matter of global corporate citizenship, sustainable design means making decisions to ensure future environmental stability. Well, that's all I had for today's presentation. If you want to learn more about SolidWorks sustainability, please visit our website at www.solidworks.com/sustainability.